Get connected. You're listening to Get Connected. Thanks for joining us. In this series, we discuss the various issues shaping your industry, how the changes in supplier ecosystems impact the way you work on a daily basis, how your customers consume the services you create, and how the industry as a whole steps up to the demands of the digital marketplace. Let's get connected.
Hello, listener. Let's get connected. My name is Chris Lewis. By day, I'm an independent industry analyst. By night, as I'm sure you know by now, I'm a podcaster. Welcome to Get Connected, where we delve into the issues shaping the networking industry and the experiences we all benefit from by being better connected. In this episode, we're continuing the journey into cloud, the transition to cloud native, and the shift to this more distributed architecture for the service provider environment. I'm delighted to welcome Pavan Kurapati, Chief Architect, SP Global Architecture at Juniper, back to Get Connected. Welcome back, Pavan, and please remind us of your background and your role within Juniper.
Thank you, Chris. This is indeed my pleasure to talk to you again. I am the Chief Architect of Global SP Architecture for Juniper, and in my role, me and my team are responsible for all the emerging technologies that our service provider customers are investing in, and we make sure we develop the solutions that are more forward-looking for the SP customers.
So to start us off then, we're talking about this continued journey into the cloud and the migration, the move, the change in architectures. What are the high-level transitions that you're seeing that are shaping the marketplace for you?
So the biggest trends in 5G is the transition to virtualization and cloud-native network functions. Let me start with the RAN, virtualizing of RAN and running on general-purpose hardware instead of the appliances that are more standard until 5G came. So that's the biggest trend I'm seeing in the RAN. Virtualizing of RAN is going to take place irrespective of whether you talk about the O-RAN ecosystem or not. Disaggregation through Open RAN ecosystem is again taking off. I was in Barcelona, Mobile World Congress, where everybody is talking about how virtualization of RAN is going to save a ton of cost for service providers. The SA core, the standalone core in 5G, that's designed to be fully cloud native and based on the cloud native principles, along with the services-based architecture. So that's going to change how 5G is deployed. Kubernetes, we're talking about a lot of cloud native principles here. So Kubernetes is going to be the de facto orchestration platform, whether it is for the RAN or for the core. And in order to deploy all these things before 5G, most of the mobility traffic used to be backhauled to a centralized data center where you would bring all the traffic to a central location and from there you would serve. But that is changing quite a bit now. So telco cloud is transitioning from centralized to distributed edge architecture to be able to host these cloud native network functions that I just talked about, the RAN and the core. So I think, in my opinion, virtualization of RAN, the 5G standalone core, Kubernetes becoming a de facto orchestration platform, and moving from centralized to distributed edge architecture. These are the key trends that we are tracking and working actively on.
I totally agree. And the fact is that we're talking about this more distributed architecture where we're moving the resources to where it's required to actually execute.
Right.
You mentioned RAN virtualization specifically in there at the cell site. Juniper is known for its work around the transport, as you said, and the traditional routing that we've seen in place. How are you seeing the cloud native developing, and how is RAN virtualization impacting that?
That's a great question, Chris. So the RAN, as I said, is getting virtualized, and especially with the RAN disaggregation, there are cases where you run the DUs at the cell site itself, and if it's a virtualized DU, it runs on a general purpose x86 based server. So we do have physical cell site routers. Juniper provides these physical cell site routers for front haul and mid haul connectivity, and two main important aspects of cell site routers are timing and synchronization, especially Class C timing and hardened cell site routers, as well as the routing stack required to support the network slicing capabilities. Now, for some distributed RAN architectures, especially where you only require sub 25 gig or sub 50 gig mid-haul capacity, this is where things become a lot more interesting, because here you might save operational expenses if you eliminate an additional physical device at the cell site. And that's where Juniper is working on what we call as a cloud native router. The idea here is to take best of both worlds, which is Junos routing that runs on all our routers. We take that and we containerize that, which is our containerized routing stack as a control plane. And then we take our Contrail DPDK forwarding plane and deploy it as two different pods, which forms the brain of Junos and the forwarding plane of Contrail. And that's integrated with the Kubernetes CNI framework that I talked about before. So that cloud native router is where we think the DRAN deployments with the sub 50 gig mid haul will go.
And it's so interesting because we're bringing so many things into the mix here. So cloud native routing does sound very interesting at the sales side, but what kind of integration are you looking for and expecting from the RAN and the hardware vendors?
Oh, great question. Again, very minimal integration from the RAN vendors. In fact, the networking for the RAN, especially when you're looking at the DU and let's say you require three slices, one say going to VPN green, another to blue, another to red, going to three different locations. Typically, you would tend to put all that information in Kubernetes manifest, and we automatically translate that into Junos construct without you doing anything as a RAN vendor. You don't have to do any additional configurations, for example, to make that happen. From hardware, again, we understand that this is a resource constrained environment. We are talking about having very less cores for routing. And we do understand that, and we operate in a very limited core budget. So, for example, today we only need about 2 cores to run our entire routing stack and still be able to provide the required mid-haul capacity. In addition to that, we are also exploring the offloads, for example, on offloading the entire data plane on FPGAs as well as on the SmartNICs.
What I always like about this development in the industry is that nobody can do everything, but the skills being brought to the table by everybody really complement each other.
Sure.
It's a convergence of IT, of transport, of networking, of all of these things. But I think what really comes to mind when we talk about this is that the scale of these virtual elements is going to be absolutely enormous. How are you going to automate the install and the provisioning of all of these pieces?
Oh, you are absolutely right. As we talked about before, we are talking about tens of thousands of cell sites that will require these kind of features and functionality. So yes, the scale is enormous. So again, the key idea here is to follow Kubernetes best practices, because Kubernetes has built-in aspects that will take care of the lifecycle management. Just to give you some examples, so we provide Helm charts that will define and install all the routing stack, the pods that are required. So we use Helm charts. It's literally just a one line that will bring up the entire pods. In terms of provisioning, I talked to you about that before. We can take the networking constructs from the Kubernetes manifest and we automatically translate that. Terraform is very popular these days. Junos supports Terraform providers. So you can actually come in and provision things using Terraform. In addition to that, it is a regular Junos. It's just in a cloud native form. So we support all the interfaces that are exposed in Junos. For example, the netconf, and you can come through PSEP, you can talk BGP, you can use our RPD APIs. You can use exactly the same way that you would use any other Juniper device. So that's really the key. For us, automation is very, very important at this scale, and we are doing everything to utilize Kubernetes ecosystem.
You're talking tens of thousands, potentially even more than that. The densification of the network as we move into the 5G world and farther on into the 6G world means that we're going to get denser and denser and denser. So forward looking, we really have to nail this in terms of making sure we can automate and deliver it.
Right, exactly, absolutely.
So that looks to be, from a disaggregation perspective, a great story in the transport. But talking about disaggregation more generally, and especially in the RAN, how do you see the Open RAN, and how does Juniper see the Open RAN environment and the benefits it brings to the service providers?
Right. As I said, I was in Mobile World Congress and I could hear a lot of people being very positive about ORAN taking off, especially the open interfaces that are essential for the ORAN ecosystem, right? So disaggregation, traditionally, when you talk about RAN, it's vertically integrated into an appliance. Now the disaggregation allows you to divide it into multiple components, and you can mix and match, right? You can mix and match the RUs, DUs, and CUs with multiple vendor ecosystem. So that's really, really healthy for the service provider networks. So one of the key aspects we are also noticing is, the decoupling of RAN intelligence and removing some part of the intelligence away from the traditional appliance and deploying it as applications. Like use AI ML to get the data from the RAN and deploy it as an application ecosystem. So we see that RIC, which is the RAN intelligence controller, that provides a thriving application ecosystem in the form of XApps and RApps in the marketplace. So all the intelligence is going to be, I think, in the applications. We're talking about spectrum utilization efficiencies, for example, like 30 to 40% of savings in spectrum utilization, sustainability as an aspect, SLA management, and so many applications that can be developed in this environment, especially in the RAN disaggregation. So we do believe ORAN, especially in the RIC and the application ecosystem that is provided through the ORAN approach, is going to be crucial for 5G deployments.
That supplier ecosystem is so important, but speaking specifically about RIC, which is gaining such a lot of attention at the moment, how do you see that being deployed?
We are designing RIC to be cloud native from day one. The platform itself is being built on cloud native principles. So what it means is RIC can run on service provider private cloud platform that is there in their on-prem, or if they're using a hyperscaler platform in their premises, the RIC can run on that platform as well.
That flexibility of where the RAN is running obviously fits in with what we're seeing in the service provider community, where they're looking at all sorts of different implementations, their own environments, as you said, or indeed in the hyperscaler world. Now, we've talked a lot about RAN. In mobile networks, the EPC in the 4G world was where that virtualization really started. The 5G standalone core is cloud and microservices based. What opportunities does Juniper see in the virtualization of the 5G SA core?
Great question, Chris. So 5G core vendors, as I talked to you about 5G core previously, it is designed to be microservices based, and you will require an orchestration platform to host these network functions. And typically 5G core vendors try to sell their own vertically integrated platforms to host their core applications, claiming that you will get better performance of their core running on their platform. But I think we are seeing operators looking at this as an opportunity to disaggregate and build a horizontal cloud platform where they can run these 5G core network functions to avoid the vendor lock-in. And this is where we see a big opportunity for Contrail. So today we have 5G core, even the 4G virtualized core running on Contrail based horizontal cloud platforms where Contrail provides the overlay networking. Initially, we did all this work with OpenStack, but now we are seeing this migrate to Kubernetes-based ecosystem. So from our point of view, we think Contrail networking provides huge differentiation, especially with respect to providing advanced networking features such as BGP as a service, advanced security, especially in the multi-tenant and the namespace network isolation and other aspects, the multi-cluster networking, which is very important in the 5G standalone core deployment. So all of these are key differentiators from networking point of view when you are talking about building these horizontal platforms. And that's where we think Contrail networking is evolving into more cloud native form. We call it cloud native Contrail networking, or CN2 or CN square. The other aspect, which is also very important, is the underlay networking, where you have leaf and spine, you need to provision and configure, but more importantly, it need to integrate well with the orchestration platforms that you are using for the standalone core. And here is where we think our intent-based fabric management, which is Abstra that Juniper acquired, plays a very important role. And we have been helping various operators with the Abstra as well as Contrail based horizontal cloud platforms to be able to host these 5G cloud native applications, especially in the standalone core.
What is fascinating here is, as you quite rightly pointed out, the underlay and the overlay, building these things together, and you brought those into Juniper to help in your delivery. But what we're also seeing is announcements about some of the telcos working with the hyperscalers to move workloads such as 5G core into those hyperscaler environments. So we've seen it with Dish with AWS, and we've seen it with AT&T with Azure. How do you see Juniper fitting into this hyperscaler ecosystem?
Again, another great question. We do see these trends, as you said, moving into hyperscalers, especially running these virtualized network functions in the 5G space, whether it is RAN or core, requires you to invest in the infrastructure and the platform. So one of the aspects that some operators feel is easier to do is simply run it in the hyperscaler environment, right? Where hyperscalers would provide the required infrastructure and platform, and you can just take care of the network functions or the applications here, whether it is the core or the RAN. I think some of the challenges that we are seeing is it's not just about having the 5G core running in a hyperscaler environment. Things just come up, but it's about connecting these 5G core network functions or interconnecting them. That's where there are a lot of challenges because the networking requirements, for example, to host the standalone core, you will need network segmentation, you will need to extend your current VPNs in your on-prem data centers into the hyperscaler data centers. So terminating those overlay tunnels as well as to be able to provide network segmentation. These are challenges that you will find in all three hyperscalers, to be honest. And that's where we come into picture. We are very actively working with all the three hyperscalers to address these networking requirements. I talked about Juniper CloudNative Router in the ORAN space before. It's actually the same CloudNative router that we are working with the hyperscalers to be able to deploy in an autoscale cluster, which will provide these network segmentation capabilities and be able to interconnect these VPCs that are hosting the 5G core elements. So in a nutshell, we think that is an opportunity for us where if the service providers are looking at hyperscalers to host these network functions, we come in and help them in connectivity and automate all the connectivity aspects, whether it is between their edge cloud and public cloud or between the VPCs within the public cloud.
And it's fascinating, isn't it? It's these little elements in between. So it's working with the hyperscalers. So it's not one part of the ecosystem imposing a way of working on the other. It's the visibility that you're bringing to the table, which will allow all of these different flows to work correctly in the long run.
Absolutely. Absolutely. Yeah.
And we've talked primarily here about the wireless environment because, of course, 5G gets a lot of that attention from the marketplace. But what about the wireline side? Do you see similar trends on the wireline side of the argument?
Oh, yeah. I mean, the disaggregation, that is true even in the wireline world. Take an example of BNG. We are talking about CUPS, which is the control and user plane separation. That's already happening. So the BNG control plane is already separated and it can be run as microservices in any cloud platform. So today, we have our BNG control plane, which is completely microservices based. It can run on on-prem cloud. If you are using any on-prem hyperscaler infrastructure like AWS Wavelength, for example, we can run the BNGC even on an hyperscaler infrastructure. The key is you need to design it right, follow the Kubernetes-based ecosystem, and the same principles apply to wireline world as well.
It's great to hear because I think all too often we don't think about the fact that as consumers, we take wireline services, we take wireless services. We want that quality of service to be delivered throughout. And what is becoming increasingly evident is that we need the different players in the ecosystem. So people like yourselves, people like the hyperscalers, and of course the service providers themselves to be working much more closely together to have that management to make sure that reliability gets delivered through to all of us as users. Pavan, fantastic to have you with us again. Thank you so much for having joined us on Get Connected.
It was great talking to you, Chris. Thank you so much for having me.
So there you have it, listener. We continue this journey into cloud. We continue bringing together the elements of the cloud environment, the service providers, and the ecosystem of suppliers to be able to work with everybody to deliver the quality of service that underpins the future of the digital marketplace. Not only is it required in the wireless world, it's required in the fixed world as well. we bring together the benefits of having this continuous integration, the continuous management of all of the services. We're beginning to build that momentum as cloud brings all of these capabilities to give the scale that we need to support all of those services in the future. Thank you for joining us on Get Connected. Thank you to Pavan, thank you to Juniper, and thank you too for listening.
You've been listening to Get Connected. You've heard from us, now we'd love to hear from you. Tell us what you think via Twitter using the handle @JuniperNetworks. And if you like what you've heard, remember to tell your colleagues and friends. Thanks for listening to Get Connected.